Hello and welcome. Thank you so much for taking the time to participate in today's session entitled Helping Students Make Sense of Mathematical Word Problems. This will be a foundational introduction to schema-based strategies. As para-educators, you are such an essential part of the instructional team. Many times, you are the person sitting beside our students during some of their most challenging learning moments. The purpose of this training is to help give you a better understanding of what schemas are, why schema-based strategies are important and useful, and how you as a paraeducator can support students during mathematical word problem solving while also promoting student independence, confidence, building language, and mathematical reasoning. I am so excited to be with you today. My name is Billy Jo Monday, and I am a staff developer at the Lincoln Intermediate Unit. My two main areas of support are with the MTSS Math and STEM initiatives, as well as inclusive practices. Throughout our time together, I am hopeful that the information shared will remind you of your existing knowledge, give you opportunities to refine your current practices, and possibly even replace outdated habits with more effective strategies, as well as I am sure many of you will be reaffirmed in the excellent work you are already doing. This session will provide a foundational understanding for what schema-based strategies are and how they help students to conceptually recognize those underlying structures of word problems so that they can make sense of what is happening mathematically and be successful problem solvers. Throughout our time today, we will be taking a look at why word problems are so difficult for so many of our students. We will look at what schemas are as we take a look at the common types of schemas and also focus in on how you as paraeducators can support students effectively through language prompts and guided questioning. Let's begin by thinking about why mathematical word problems are so difficult for so many of our students. I would like for you right now to start to bring to mind some students who you may be currently working with or who you may have supported in the past. And I want you to reflect on what challenges you are seeing or have seen them experience when solving word problems. I would also like for you to consider when they get stuck, what do you typically do to help support them? You may jot your thoughts down individually or discuss within your groups if viewing this session with others. So at this time, I would invite you to pause the video and reflect. Welcome back. So, what did you jot or what did you discuss? I will bet that many of you probably said that the struggle you see is that word problems are a reading task first. Before our students can even touch the mathematical computations, they have to read and understand the situation, which may mean that they have to decode academic language. They have to hold a lot of details in their heads and make sense of what is happening. For students who may already struggle with reading or have trouble with focusing and attention, that's a lot to do before the math even begins. Or was it that you were thinking that maybe the struggle you're seeing is that your students just aren't even sure what the question is asking? Many students just jump straight to those numbers. We call those our number pluckers, right? They just grab the first numbers that they see and start an operation with just a guessing game and hoping for the best. But this actually probably is happening because they miss the actual question, or perhaps they're focusing on details that don't really even matter in the problem themselves. Maybe they're not even sure what the goal of the problem is. And so when our students don't know what they are solving for, everything feels confusing. Did you say that maybe there was no clear problem-solving routine for your students? And that's where the challenge came in. Because without a consistent structure, word problems feel very different every time. And that can cause students to really get frustrated quickly, which then in turn causes that guessing game to occur. Or maybe they start just attempting multiple steps without a plan, feeling unsure where to start even. A lack of routine makes problem solving feel unpredictable, and that is where some frustration and anxiety can start. Speaking of that, cognitive load, right? Are the word problems asking our students to do so much all at once? They have to read and understand the text. They have to make sense of the situation, decide what the question is asking, choose a strategy, do the math, check their work, right? Phew, let's look at that again. That's a lot. So yes, word problems can be difficult for many of our students for many reasons. And sometimes students may understand the math computation skill, but possibly struggle to understand the language of the problem, or organize the information, or even determine what the problem is asking. So, now that we have discussed the many possible reasons our students may have difficulty in solving word problems, we can truly start to understand why today's session and part two of this training will be so valuable as we learn more about what we as paraeducators can do to support our students in reducing some of that cognitive demand, which can also decrease student frustration by showing this process in a slower, more meaningful way. So, before we go any further, let's think about that. Schema. What is it? Think for a moment in your own mind. If you were needing to define it, what would you say it is? Schemas are those underlying structures, those conceptual frameworks that are used to organize and interpret information in a word problem. They're often referred to as problem types. So, simply put in a nutshell, a schema is a problem structure that helps students understand what is happening in a mathematical situation and how the quantities are related. So one of the things I like to do is stop calling them word problems and actually calling them mathematical stories, because that's what they are. That's where schemas can help students recognize those story patterns, organize the story's information, understand the relationships that are occurring, determine that relevant versus irrelevant information, and also select the appropriate strategies and operations needed to solve more accurately and efficiently. So I'm going to stop there for just a moment and really go back to that idea of choosing an operation. Because throughout our time today and in the next session, when we think about schema-based strategies, we want to really help our students move away from over-reliance on keywords when attaching them to operations. But please let me make myself clear. My message today isn't that keywords are bad, but rather that keywords should really support the comprehension of what is happening in the story, not determine the operation. Keywords, you can think of them like like road signs. They can give a lot of useful information about where we're going, but we wouldn't want to drive by looking only at the road signs and miss the road entirely, right? Students need to consider the entire mathematical situation, not just one word. So our schema-based strategies are going to help our students to use keywords as a part of the understanding of the story, while also considering the relationships between the quantities. So, what do I mean? Let's look at the example here. Maria has 12 stickers. Jamal has 5 stickers. How many more stickers does Maria have than Jamal? Stop and think. What would your students probably do with this problem, especially if they were really honing in on a keyword? Did you say add because they saw the word more, right? If they have learned that every time I see the word more, it means to add, then they probably solved this by saying 12 plus 5 equals 17, which is incorrect. But if they see that Maria has 12 stickers and Jamal has 5 stickers, how many more stickers does Maria have than Jamal? And they start to think about what the problem is actually asking, they're noticing that the question is asking them to compare two amounts. They're comparing Maria's stickers, 12, to Jamal's stickers, 5. And when they do that, they see that they need to find the difference between those amounts. 12 minus 5 equals 7. Maria has 7 more stickers than Jamal. So we can see here that attaching keywords to operations are not always reliable. The word more appeared in the problem, but the operation to solve it was subtraction, not addition. Keywords can provide those clues, but they do not determine the operation. Students must think about what is happening in the mathematical story. For instance, let's look at this without a schema. A student reads, Maria has 12 stickers, Jamal has 5 stickers. How many more stickers does Maria have than Jamal? So without the schema, leading to the addition, they probably are saying, should I add? Should I subtract? What does how many more even mean? Right? Thinking back to those struggles we just talked about. But when our students are really looking at the underlying structure of a problem, the schema, they're reading that same problem and they're beginning to recognize that this is a compare problem because it's comparing two amounts. The schema provides meaning because it helps our students to understand that there were relationships between those quantities before they were deciding how to solve them. So why do schemas matter? Schemas help to move our students from simply guessing to mathematical reasoning, thinking structurally, having a deeper conceptual understanding. So, again, in a nutshell, schema-based instruction teaches students to think about the mathematical situation before thinking about operations. Students identify that relationship among those quantities, and then they determine the strategy for solving the problem. So, as we think about that, here are some high leverage guiding questions that you as paraeducators can use to promote thinking instead of really just number plucking or attaching keywords to operations. No matter what the problem types are, we can support our students by asking them guiding questions. This, say this, not that, is very helpful. Instead of us saying, is this addition or a subtraction problem? We may support our students by asking, what's happening in the problem? Are we combining amounts? Are we comparing? Is there an amount that's changing? How many quantities are we even talking about? What is the question asking us to find? And what relationships are you noticing between the quantities? So here I'm going to provide you with an effective 3-step support process that you can use to help students develop their mathematical reasoning while they are solving word problems, but it's also helping them to identify the schema. So let's take a look. First, helping students to identify the schema, you might use prompts such as, what is happening in the story? Are parts joining together? Are we comparing? Are their amounts changing? Next, after the schema has been identified, you can help guide them in visually representing the problem, whether that's through a schema map or bar model, whether it's through a drawing or sketch, or even using manipulatives, depending on where your students are in their acquisition of their learning. We can help them to maybe map out or draw their bars appropriately if they're using a bar model. Remind them to label known quantities and leave unknowns blank. We really just want to encourage students to make their thinking visible before solving. Third, we then want to guide our students to connect those visual models to the equations when solving. So that might mean we might ask something like, what equation matches your model? How does your drawing help you to solve? And this is going to allow our students to see the connection and prevent them from seeing drawing and computation as separate tasks. So, a great way to help scaffold their thinking is by modeling gestures for different problem types. These help anchor our student thinking and provide a deeper conceptual understanding. Schema gestures are just physical hand movements used to help students sort of map out those structural patterns that they're seeing in word problems. And by pairing a specific gesture with a problem, they are able to really have more of a retention and understanding of the actual meaning of the problem. So why do we use them? Well, they're providing those multi-sensory learning experiences for our students and helping some abstract concepts become a lot more meaningful and tangible for our students to remember. But before we watch a video that demonstrates these gestures, I'm going to introduce you to each of the problem types. But keep in mind that this is a foundational session where we are learning about the role of the schema in helping students make sense of the mathematical word problems and how to facilitate student thinking through questioning, modeling, and language supports. But we will, in our second session of this training, take a deeper dive, a more advanced look into how to identify those different problem types and use attack strategies to support our students to solve them. So, first, what are the two main types of schemas? Well, they are additive, which is requiring our students to solve using addition and subtraction, as well as multiplicative, which are really focusing in on multiplication and division. Those are overarching schema types or problem types. But then within each, we have more specific structures, such as in our additive schemas, we really focus in on total schemas, difference, or change as we look for patterns in word problems. Whereas in our multiplicative, we are really focusing in on those equal groups, set comparisons, and then eventually in our upper grades, those ratios and proportions. So when we are thinking about our total groups, we are really thinking about parts being put together for a total. Notice I said parts, not just one part plus two parts, right? When we are looking at parts, we are looking at sometimes multiple parts, not just two parts. When we think about our difference, we are really looking at comparing amounts we have a greater amount versus a lesser amount, and we are looking at the difference between them. For our change problems, we are really looking at whether an amount is increasing or decreasing over time. With our equal group schema, starting our multiplicative schema groups, we are really looking at whether we are seeing, are we looking at groups with an equal number in each group? Whereas in our set comparison, we are trying to determine if we have a set multiplied a number of times. With our ratios and proportions, we're really looking at those generalizations of if this set is to that, then this set is to that. We will now watch a video where Dr. Sarah Powell shares the different gestures we can model and teach our students to use when trying to identify word problem structures. You can find this video and many other wonderful free resources at mathspiral.com. During our time together, we are going to notice these things over and over again. So let's look now at the video.
Hi, welcome to this Stair Tailored. My name is Sarah Powell and I work at the University of Texas at Austin. Today I'm here to talk to you about word problem instruction, and we're going to focus specifically on the gestures that we can use to describe different schemas. Now, when we think about a schema tells us what is the structure of the word problem. Really, like what's the meaning of this word problem? And there are 6 schemas that we see regularly used across the elementary and middle school grades. So we have total difference and change problems. Those right here are additive schemas. And then we have equal groups, comparison, and ratios and proportions. And those are our multiplicative schemas. Now we can use gestures to help students really think about, well, what does this word problem mean? What type of schema is represented in this word problem? And now I'll show you some examples. So first we have total problems. Remember, in a total problem, we have parts put together for a total. So we like to hold our hands apart and then put them together to show parts put together for a total. Do make sure that when you are describing total problems that you do not say 2 parts put together for a total, because then that's not going to work very well with 3 and 4 part total problems. But you can just say our parts put together for a total. With our next additive schema, we think about difference problems. In difference problems, we have a greater amount and a lesser amount, and we compare those for a difference. So I like to hold up one hand here. This is the greater amount, the lesser amount, then we kind of shake them back and forth to think about the difference between the greater and lesser amounts. You can also show this on a number line orientation, so I could ask about the greater amount and the lesser amount and comparing those for a difference. Now in change problems, we have one amount that increases or decreases. So for gestures, we say kind of put one hand down to the side or sometimes behind your back, and you say I have one amount that increases or decreases. Again, one amount that increases or decreases. If you also wanted to do this on a number line, that would be fine. You have one amount that increases or decreases. Either of those will work. And the real big emphasis here is that you have one amount and something is happening to increase or decrease that amount. Now for equal groups problems, this helps us segue into our multiplicative word problems. And in equal groups problem, we have groups with an equal number in each group. So we'll hold out our hand like this. I have my clicker in my hand, but you would not probably have that. But we have equal groups with an equal number in each group. So just kind of showing the dip of the equal numbers in each groups, just like that. For comparison problems here, we have a set that's compared a number of times. So here with a comparison problem, I show my set, and then I'm going to show hops along a number line just like that. So we ask students, is there a set compared a number of times? And then for ratios and proportions problems, here we're looking at the relationships among different quantities. So we'll ask students, well, if this is to that, is this to that? So then we're showing those 2 proportions and the relationships among those proportions with our hands. So that was a quick review of how we can use the word problem gestures to help students understand the structure of word problems.
Okay. So, aren't schema gestures wonderful physical representations of that problem schema, those underlying structures? Remember, our students become stronger mathematicians when they learn to make sense of situations, recognize relationships, and explain their thinking. That also helps them to persevere through challenges. So, at this time, let's revisit our learning intentions for today's session. During our time together, we explored how schemas help students make sense of mathematical word problems by focusing on the relationships between quantities rather than relying solely on keywords or guessing an operation. We also discussed how you as paraeducators can support student thinking through guided questioning, schema modeling, and language supports that are strengthening our mathematical reasoning and problem solving skills in our students. The resources that I mentioned are here again. That video that we just watched, can find that at mathspiral.com, along with a lot of other really valuable free resources. Another is that Pirate Math. And the 13 Rules That Expire is an article that is really useful and very beneficial. It also gives you a lot of information with that say this, not that, and things that have expired, those old habits being replaced with better, more effective practices. And then I also included here the great middle school's schema-based instruction videos because as you get it into maybe supporting higher level grades or even your own children, those can be very beneficial as well. So here are just a few reflective questions to ponder as you consider what your next step will be as you work with your students that you support. I just want to thank you so much for joining me today and for your commitment to supporting students. I hope you can join me for part 2 of this training as we will apply the strategies of today's session to dive deeper into supporting our students by helping them identify those different schema structures and word problems and how to effectively use a cognitive attack strategy to solve them. Remember, the questions you ask, the language you model, and the encouragement you provide can have a lasting impact on how students approach mathematical problem solving. I wish you and your students a wonderful school year.